Okay, now I'm going to start my topic, that is a red black tree. So red black tree, it is a tree, as we know about the avial tree and binary search tree. So very in summarized way, I can say red black tree is a combination of the binary search tree and then avial tree. But it is necessary if you are looking for the avial tree, then you must be familiar with the binary search tree. And if you are looking for the binary search tree, then it is necessary your tree must be binary tree. So the sequence is going on, like first we have the binary tree, then we have the binary search tree, then we have the avial tree. So for understanding the red black tree, it is necessary again to understand avial tree. So already we have seen what is mean by the avial tree and what is the purpose of avial tree. So that's why avial tree is the most important part of the our tree mechanism. Binary tree, binary search tree, able tree, and then a red black tree. So red black tree is basically is what? This is self-balancing binary search tree. But in the case of the able tree, the user or the people, we have to adjust followed by the sum its rotation. Those are the LL rotation, LR rotation, RL rotation, and RR rotation. So in the able tree, we have already discussed this kind of situation so many times through the various examples. Now come to the points red black tree. Yeah. So indirectly, I can say red black tea. For understanding red black tea, it is necessary that you must have some idea about the evil tree, and for the evil tree, you must have some idea about the binary tree, and for binary tree, you must have some idea about the binary as well, and for binary, you must have idea about the tree. So this sequence basically we have. So I'm speaking few points over here that is necessary for the our class. Red black tree is a self binary search tree, a balancing binary search tree, not a self binary search tree. It is self balancing binary search tree in which each node contains an extra bit for denoting the color of the node. That could be the red and black. So this is a theoretical part or the historical part we have over in the in 1972, the by Rudolf Weir, and who termed this term, that is a symmetric binary B tree. So that is recognized by the red black tree. So I'm not going to the historical part, so I'm just coming to the important part for the understanding purpose. A red black tree is a binary tree where us or where a particular node has color as an extra attribute, either red or black. So what we have as a name given on this tree, that is a red black tree. So we have the red and black, two different colors. So with help of these two different colors, we will draw our tree, and that is known as a red black tree. And during preparation or during the creating the tree, or adding the node or deleting node, we need to see the tree is balanced or not. So definitely able trees concept will be integrated over here, and while balancing it is necessary to maintain the properties of the binary search tree. So of course BST is important part. Since we are talking about the BST, so definitely our tree must be the binary tree. So definitely each and every concept what we have discussed so far, it is most important part for understanding the red black tree. So let us understand through the simple concept, and those are recognized by the properties. So what are the various properties by which we can represent the red black tree? So property number one, we can say a red black tree must be binary search tree. Okay, so red black tree must be binary search tree, as I speaking again. So it must have some idea about the binary search tree as well as evil tree. Evil tree I can't say directly, because evil tree just means a tree which is used for balancing your the tree, but user is required to involve. But in the red black tree, it is self balancing followed by the its nodes, and which each and every node will be represented by the own different color. Those could be red or black. But how we can say which node should be red, which node should be black? So with help of the various properties of the red black tree, we will see. So property number two is saying that the root node must be colored by black. So keep in mind this important term while we are saying the root node. So root node must be black. And property number three is determining that the children of the red colored node. Please keep in mind the term in your mind. The children of the red colored node must be colored black. Okay, so keep in mind the children of the red colored node must be colored black. and there should be two consecutive red nodes. So please keep in mind that these important terms. Now property number 4. In all the parts of the tree, there should be the same number of black colored nodes. So all the properties are necessary to understand the red black tree designing or red black tree creating or creation. So property number 4 is saying that in all the path of the tree there must be same number of black colored node. I am going to again property number 3, that is the children node of red colored node must be colored black. It means there should not be two consecutive red nodes. So please keep in mind this is important, but we will see through this concept through an example. So I am again going to the property number 4 once again. In all the path of the tree there must be same number of black colored node. And next we have the property number 5, that is every new node must be inserted with the red color. So if you're trying to add a new node, that should be colored by the red only. So we can't take this could be a black node. And every leaf node, that is a null node. Okay, so leaf node means or a null node means the last node, and which is represented by the null node, and that must be colored by the black. I will show this properties example through an example, so you will see in clear way. So I'm just coming to the back to the my part, that is a red black tree or basic concept. Now do you have any doubt over here what is mean by the red black tree? If you have any doubt, then you can ask me, or shall I move ahead?
No doubt, sir. We can
No
move
So,
doubt,
ahead.
sir.
so red black tree means a tree which is having the properties of the tree, BST, and then evil tree properties. We can say somehow we can say include, because balancing is required in the red black tree. So before understanding red black tree, you must be aware about the ABL tree, body search tree, binary tree, and tree concept. So okay, so this is a sequence. I am going through that part only. So again, properties we have seen. So properties in summarize, we can say the root must be black color, and if you try to insert a new node, definitely the new node will be colorized by the red color, and the leaf node always represented by leaf node, that is null node. Okay, keep in mind this is important. From I will see you through an example. So this is the important part of the properties. Again, we can say there are lots of the properties, so we have put it over here only the 6 properties by which we can compromise or integrate it in our red black tree, or we can create a new red black tree by pulling these properties. Okay, so I'm going to the again few properties. These are the few properties taken from the books as well. So red black properties, you can say that every node is colored either red or black. So this part of this properties we have already discussed. Now root property, root must be black. Okay, so this part also we have discussed. Leaf properties, it means the leaf, that is nil, is black. So we have seen already this part. Now question comes in our mind, sir, what is mean by the leaf node and nil node? So nil node means leaf node is a node, that is last node which contains some information, but after the leaf node there is some nodes are available that is recognized by the nil. Why nil? Because when we are implementing the tree implementation followed by the linked list approach. So at the last, you will keep in mind the important term, that is last node determined by the null. So null means there is no more ahead, there is no more nodes are ahead of this node, and that is represented by the last node. So the null represented means that there is no more nodes are connected to its linked list. Okay, so definitely the into the tree node, in the tree we can say after leaf node there is no more nodes are connected, or there is no more children are available of the node. So the leaf node, or after the leaf node we have the null node, that is mean by the nil node, or we can say that is known as the null node or nil node. So I will explain this concept through an example. That's why I'm saying again. And now red property means if a red node has children, then the children is always black. So please keep in mind the important term. If a red node has a children, then children are always becomes a black node. And depth property, so for each node any simple path from this node to any of its descendant leaf has the same black depth. Please keep in mind this is the I'm speaking once again. For each node, any simple path from this node to any of its descendant leaf has the same black depth. and that is represented by the number of black node. And through this slide you can see we have this term through the properties number 3. So the children in the red color node must be colored black. It means there should not be two consecutive red node. And in the property number 4 we have already determined this part, that is the in the all the path of the tree there must be the same number of black colored nodes. Please keep in mind property number 4 and the depth property over here are the same, and we will see each and every concept through an example, so you will learn a lot. So this is the example of the red black tree. So as we know, the root is what? Root is our definitely in form of the black color. So undoubtedly we can say this is our root node. So let me take some uh, diagrammatic way so you can see. Okay, pen color. So this is our root node. Okay, so root is always must be black. And now next we have the red node. Here we have the black node. So left side and right side you can see the or left children or left child or right child is just having own different color, definitely red color or black color. So each and every part is followed by the property basis. And now keep in mind the properties, keep in mind this property. Every red node must have the black children. So we are having this property. Okay, keep in mind this point. And if we're talking about the this null node or null means 15, 11, 31, 41, and 61, these are the nodes. These are recognized as a leaf node. I am repeating once again, these are known as the leaf node. Okay, but while about the nil node means determining the after the 41 there is no more children are connected, so that is represented by the nil. So it means in the 41 node, that is a leaf node, having the its two different null nodes. So of course without any doubt properties of the binary tree, every tree node, every parent node or every root node must have its own two different children. So all those are recognized by the null node because there is no more nodes are connected. So this is an example of the our red black tree. Now if you have any doubt over here, then you can ask me. uh,
सर
yes, yes, yes.
सर ये 13 रेड है और ये 53 ब्लैक है सर, ये कोई प्रॉपर्टी की वजह से है क्या सर?
नहीं, ये जब हम क्रिएट करेंगे तो इसको हम देखेंगे कि ठीक है, अभी मैं बताऊंगा एक एक करके कि कैसे कैसे चीज़ें मैनेज हो रही है। क्योंकि 33 तो आपका रूट है, एंड जैसे आपने ऐड किया तो आपने जब नया नोड ऐड किया तो 13, ठीक है, या 53 जो भी ऐड किया आपने। पर हमको क्या करना है कि जब हम इसको इंसर्ट करेंगे, जब क्रिएट करेंगे, तो व्हाट वी हैव द सम पार्ट्स और some steps. Okay, and those are known as a recolor or re-rotation. Because होता क्या है कि what happened at the time, the rotating time we need to see in the able tree we have seen while uh, rotation. So the node which is a children node or child node, that could be becomes a root node. So after the rotation depend on the LL rotation, RR rotation or RL rotation, depend on the what kind of notation you are using at the time. The children node or child node may become a root. So it's basically what happened, it is a basically properties of the its balancing. So while balancing the all the nodes here, keep in mind, you need to keep in mind we have the some different concept, and those are known as recolor. And okay, so with the help of this concept you will see. So while inserting a new node into existing red directory, so we will have a concept. So we will see this part through an example. So please do not much bother about over here right now the color, but please keep in mind the few properties. So those are necessary. And what are those are necessary? A row red node must have the two black, must have. अगर मैं बात करूँ तो 15 के बाद अगर मैं कोई नया ऐड करूंगा तो वो नया ऐड जो कलर करूंगा उसको कलर कौन सा करूंगा, ब्लैक ही करूंगा। सपोज मैंने ऐड
ब्लैक
करा
सर।
यहाँ, राइट ना, सो ब्लैक ही करूंगा ना। सब 15 के बाद अगर मेरे यहाँ कोई नया नोड आएगा तो व्हाट इज कलर, वो ब्लैक से होगा। ओके, सो इसके जितने भी चिल्ड्रन होंगे 15 के, दैट कुड बी लेफ्ट और राइट चाइल्ड, सो ऑलवेज रिप्रेजेंट बाय द ब्लैक कलर ओनली। ओके, So this is the most important part. So ये part आपको थोड़ा manage करना है. So that is we will see through an example. So you will learn a lot. So red black tree is very simple
सर
tree, but if you, yes, yes.
सर अगर सर 15 के आगे सर नोड्स ऐड करें तो सर 15 का कलर चेंज होगा क्या सर?
15 का कलर चेंज होगा नहीं होगा, वो इस बात पे डिपेंड करता है कि ट्री बैलेंस है कि नहीं. अगर ट्री बैलेंस करेंगे तो यू हैव टू सी इम्पोर्टेंट पार्ट. ओके, आपको देखना पड़ेगा,
यस सर।
है ना. तो बैलेंस करेंगे तो
सर
कौन, हाँ, बैलेंस करते वक्त ये देखना पड़ेगा. होगा क्या, अभी हम देखेंगे एग्जांपल के थ्रू. होगा कि जैसे हम बैलेंस करेंगे तो 15 हो सकता है कि चाइल्ड हो जाए और ये इधर जंप कर जाए. तो जंप करेंगे तो 15 ऑलरेडी कलर उसका रेड था, तो ऊपर जाके क्या हो गया, ये आपको रेड रहेगा. पर इसके जो चिल्ड्रन नोड होंगे वो ब्लैक होने चाहिए, ठीक है. पर लेकिन वो कह रहा है कि इसके ऑलरेडी चिल्ड्रन रेड हो गए, तो टू रेड कॉन्जिक्यूटिव नहीं ले सकते हम, है ना. टू रेड टू कॉन्जिक्यूटिव नहीं ले सकते. तो होगा क्या, फिर उसको हम रिकलर करेंगे. सो दैट इज नोन एज रिकलर प्रॉपर्टी. Okay,
ओके सर.
let us understand through an example. I am just coming to the part. Okay, with so वो हम देखते हैं. Don't worry about it. Okay, so each node has its following attributes. One is color, next one is key, that is value, and the left child and right child, and we have the parent. So except root node. Okay, except the root node, we will see the parent. So these are the few important parts of the each node and which are necessary to understand the red black tree. So we can say these are the attributes. So while managing all the attributes, you need to keep in mind if this tree is balanced or not. Okay, I am saying once again, I have added the 15, I have added the 7 or 8. Suppose I am saving adding the 7 or 8 over here after the 15, but tree is balanced or not. So while balancing the, we need to keep in mind, so it is determining that, keep in mind what I have written over here. Red black tree is a tree, it is a self balancing binary search tree. In the evil tree, we are performing the some rotation. Those are the LL rotation, RR rotation, and LR rotation. And next one is RR and RR, RR and LR and LL. So these are the four different rotation we have already discussed. But we are talking about this kind of tree. So what we have? We have the self self balancing. Here we have the self-balancing binary search tree. So now I'm coming to the main important part without wasting much time for your betterment, then you can understand. So we have an example. Okay, yes, I'm coming directly to the example. Then we will have some different part. Now, inserting a red black tree. Okay, inserting insertion into the red black tree, and with the help of this algorithm, we will see how to create a red black tree. Okay, so please keep in mind the important term. So while inserting a, okay, please I once again request to all the please unmute yourselves. Okay, so I can speak properly. So in the red black tree, what we have, if you try to add a new node, so that is recognized by the new node. Okay, so if you're talking about the new node, if you try to insert a new node must be colorized by the red color. New node must be colorized by the red color. So while inserting a new node into a red black tree, please keep in mind the node must be colorized by the red color. And at the time performing its operation like insertion deletion, we need to keep in mind the recolor, rotation, and rotation followed by the recolor. So you have to recolor and then rotation after the recolor. So this is the all kind of the basic operation we have to perform. So recolor, rotation, and rotation followed by the recolor. So rotation could be L rotation, rotation could be R rotation, and so on. So rotation, these are the four different kind of rotation can we have. So all the rotation which is completed or done by the able tree is also applicable over here into the red black tree as well. So while inserting a new node and as well as the deletion any node from the red black tree. So in the red black tree it is also known as the RB. So somehow into the examination I can ask what is mean by the RBT or red black tree. So in the RBT or red black tree, while inserting or deleting any node, any new node or deleting any existing node, we need to recolor a rotation, and then rotation followed by the recolor. So these are the three different operations we need to perform. So let us understand one by one, then you will understand, and whenever you have any problem then you can ask me. Now So I'm not right now directly jump onto the algorithm. So first let us understand example. So you will understand the algorithm later on. First we need to understand example how to create a red black tree. So now create a red black tree by inserting the following sequence of the numbers. First what I need to insert? I need to insert the 8. Okay. So tree is empty. So insert new node is a root node with a black color. Am I right this point? If this is okay, then say yes, or if you have any doubt, then you can interview me anytime. So tree is empty right now, so I need to insert 8. Okay, so
Yes.
what is the value of 8? So 8 is added over here, so it could be colorized by the black color without any doubt, because root must be black. Okay,
Black.
now please keep in mind all the properties of binary search tree as well as the ABL tree. Okay, or rotation, not ABL tree properties, we can say the rotations. Okay, operations. Okay, so now 8 is our root, so we have added over here without any doubt. Now tree is again not empty. Okay, so initially tree was empty, so we have added the 8, so 8 becomes a root, and now tree is not empty, so we are trying to insert the 18. So 18 is 8 is less than 18, so 18 will come to which side? Right side. Okay, am I right?
Yes, sir.
Okay, so 18 will come on the right side. Then now tree is again not empty. I'm trying to insert the 5. So definitely what happened? 5 will come into the left side. Why? Because 8 is greater than 5, so 5 will come to the left side as per the properties of the binary search tree. At this part we will discuss. Now please keep in mind the important terms. Again we need to follow the properties of the red black tree. Now what is the property? While inserting a new node, please keep in mind that new inserted new node must be colorized by the red. So 18 is in red color, and 5 is also in the form of the red color. Now after inserting 8, 18 and 5, is this okay, or any doubt
Yes,
over
sir.
here? If you
No,
have any
sir.
doubt over here, then you can ask me. No doubt, shall I move ahead?
Yes, sir.
Yes, sir, no doubt.
Okay, now tree is again not empty. I'm inserting the 15. So 15 is my new value which is to be inserted into my red black tree. So tree is not empty. So insert new node with red color. So definitely I'm inserting the new node. Okay, so as we know 5 and 18, these two nodes are already in the red color, and I'm trying to insert the new node, that is 15. I have inserted left side of the 18 without any doubt, so now it is perfect. But here we need to note down the properties of the red black tree. And what is the property? Two consecutive red node can't be possible, because what happened, it is a property red black tree, so red and then black, then red, then black. So this is the phenomena we have to go for. So here there are two consecutive red nodes, those are the 18 and 15, so as you can see over the slide. So new nodes parent sibling color is red. So and the parents root nodes, okay, and parent node is root nodes, as we know 18. Here we are talking about the 8. So we use a recolor to make the red black tree. So after recoloring, so 18 will becomes the 18 will becomes the black. And please keep in mind at the same number of the label must be in form of the black. So after recolor, the tree is satisfying the red black tree's properties. Okay, you have any doubt, then you can ask me. You have any doubt over here, you can ask me. Else I have a question to all. Now here, do you have any doubt?
सर सेम लेवल वाले ब्लैक होंगे.
नहीं, उसमें भी एक कंसेप्ट है, उसमें कंसेप्ट वहां लिखा हुआ है, उसको पढ़िए गौर से. Please
सर
read this point. Please read this point. The
हेलो
new
सर
nodes. Yes, hello.
हेलो सर ये
हाँ
जो
बताइए.
रूट नोड के बाद में चिल्ड्रन भी ब्लैक कलर में होंगे.
नहीं, उसको हम स्टेप बाय स्टेप करते जाएंगे, पहले इसको देखते आइए। चिल्ड्रन नोड ब्लैक होना चाहिए नहीं होना चाहिए वो हम जानते हैं, लेकिन एक चीज हमको नोट करनी है। फिर आप प्लीज यू गो थ्रू द प्रॉपर्टीज। ओके, ऑल द लीफ नोड मस्ट बी ब्लैक। ओके प्लीज, अगेन आई एम जस्ट गोइंग टू द माय बैक टू द स्लाइड। ओके, यहाँ पे हाँ ठीक है। द लीफ प्रॉपर्टी, द लीफ नोड और नील नोड मस्ट बी ब्लैक, प्लीज कीप इन माइंड। सो ये लिखा हुआ है ना ऑलरेडी, द लीफ नोड और द दैट इज नल नोड मस्ट बी द कलर ब्लैक। ओके, now we have to satisfy this property as well. Now is it okay? A leaf node must be colorized black.
Yes, sir. Okay.
Okay, so it is necessary. And now I have the lots of the examples to all. Uh, Now, with this example, we will see if leaf nodes are not color black, so we have the another idea by which we can represent. So, but before on that part, let us understand this example in the continuation manner. So, what happened now? 15 is again 15 is becomes already into the red. Why? Because it is in red, but after inserting it is noted down that the 18 and 15 are continuous manner. It is both are into the red, and that is not possible. So what is the idea? It is better idea to change the color of 18. Now this is already into the balance as well as into the following the properties of ancestry, and so definitely we can say now 18 can be colorized like the black. But 18 is the parent of the 15th, and if, 8 is the parent of the 18. So we can say the 15th parents would be the 15th parents is the root node. So 8 is the root node, and which is the parents of the parents node of the 15. So definitely we have to see the 5 is the sibling node. 5 is the sibling node of the 18, and that could be the black. Why that could be the black? It is very simple concept. 5 is the leaf node on the left side, so we can say it should be black. So it is, we have done this activity. So now we are going to that part, but it is not necessary in all in each and every cases. We need to see, we need to manage on the different pattern. And what is the different pattern? The pattern is determining the how many elements, how many nodes we are inserting, or how many nodes belong to the left side or right side. And we need to see again, it's a most important part. And now please keep in mind, I am just going to the once again for the betterment for easy solution. You can say, can I divide this tree as a right subtree, and can I divide this tree as a left subtree? Can I? मैं इसको कर सकता हूँ? This is a left subtree and this is a right subtree.
Yes.
So 18 is the root node of the 15. So definitely it would be the black as per the property of the red black tree.
Yes, sir.
And 5 itself is a part of the left subtree. So 5 again, it is itself is a root node, so it should be black.
Yes, sir. Yes, sir.
So after the inserting the 15, this concept is clear to all. Now first we have inserted 8, then 18, and then 5, and then we have the 15. Okay. Now this part is clear. Then shall I move ahead?
Yes, sir.
Yes,
Yes.
sir. Clear.
Okay. Now after inserting 17, can anyone explain after the taking the time 1 or 2 minutes, or should I explain? You can see the image on the PPT by this presentation, and see and explain me. You can take the 1 or 2 minutes if you want to explain. Else, I am here, so I need to explain. So tree is not empty as we know. So the new node, that is a 17, and that is the 17 to be added after the 15, that in on the right side without a doubt. here we have noted down that is the 15 and 17 are the again red. So 15 and 17 are the red node. So definitely two red consecutive nodes could not be possible. And while doing all these things, we need to maintain the balancing part. So new nodes, that is the parent sibling, is null. Okay. So we need to do rotation. So first we need to do a left rotation. Okay. So first what we need to do, we need to first it rotate and then recolor. So after the 15 and 17 to consecutive way, what we are doing now, these are the 15 and 17. First we need to do left rotation. Okay, so left rotation means we are moved to the left side. So 17 will come over here and 15 will come over here. Now why 17 is in the left side? The left side, the value must be less than its root. So definitely this part is correct. Okay, for balancing purpose. But again, it is not in the balance. Again, what we need to do? We need to perform the right rotation over here. Right rotation among the 15, 17 and 18. So at the time what happened, the 17 will come over here and 18 will come over here, and now 15 is will come over here. And now while maintaining the all those things, please keep in mind, after performing its rotation, 18 was black, but now 18 becomes the red. Why? Because a recolor operation we have done through the red black tree. So 17 is our right position, 15 is right position, 18 is right position. So this part is also in balance form, or entire tree we can say now balance. So balancing is already maintained, now there is no problem. But as far as the recolor is concerned or coloring is concerned, that you can see, or you can note it down from here. 17 should be 17 should be black, because I'm taking this part as a left subtree and I'm taking a part this is a right subtree and left subtree. So 5, there is no change into the 5, but right now we need to see 17 is our root node of the its children, those are the 15 and 18. So 15 and 18 definitely would be in the red, but 70 should be colorized by the or recolored by the black. So now it is also maintain the properties of the red black tree. So after the rotation we need to see this part as well. Now if you have any doubt here, then you can ask. Yes, any doubt? What happen first we need to follow the rotation and then we need to follow the recolor. It is better idea to first follow the rotation and then recolor. Do not follow the recolor and then re-rotation. Okay, so it is better idea to first rotation by rotation to balance the tree, and then we need to recolor all the nodes. Now here after inserting 17, you have any doubt, then let it be known. Yes student, any doubt over here?
No, sir.
Okay, shall I add a new node again?
Yes, sir.
Okay, now I am inserting the 25. So please see the slide and now tree is not empty, so I am inserting the 25, and 25 will be added without any doubt right side of the 18. Okay, so after inserting the 25, now let us see the tree is balanced or not. Tree is balanced or not?
No, sir.
Tree is not balanced, so it is better idea to first you can balance, or you can see you can colorize its parts. So okay, what happened here? Here the two consecutive red color red node we have, that is 18 and 25. Okay, so here what happened, it is noted down its sibling is in red. So 18 is what? 18 is red, so definitely, but 18 must be red and black, 15 must be black. So but we can't have in both, because here we are following the two concepts. So the contradiction we have over here. What the contradiction we have? At the same level, the two different its sibling also in the red color, and if you're trying to change its black 18, so that could not be possible. So suppose I'm making this is a black, okay, I'm naming this is black, okay. So 25 is okay, red, no problem. I'm making this black, but what happened? This is again black, but what happened? Black, black, and black. So here could not be possible. So I need to make this is a red, and then 15 could be black at the time. Okay, so 17, I need to change the 17 in form of the red, but before this 18 must be black. So you can perform the recolor operation. So we have done the recolor operation, but after recolor operation, it is noted down that the tree is not in a balance. So tree is not balanced, and then we need to perform the balancing property. So next part we have over here. Okay, so next part we have over here, then this showing that. So you can perform the rotation directly over here, or you can add the new element after that you can rotate. So here after the recolor operation, the tree is satisfying the red black tree properties, its properties. Okay, so it is, but again I'm saying it is not balanced, then you can manage its balance. But right now it is following the properties of the, it is following the properties of the BST. So binary search tree. So undoubtedly we can say there is no problem over here. So it's satisfying the our binary search tree. But while talking about the balancing, the rotation also required to perform over. So let us see through the after the new element. So after inserting the new element, that is a 40. So after inserting 40, it is noted down that after noticing LL is required. So left side we need to move, because here we have the two different not two different to the same consecutive color red node. The 40 will come over here, then we need to shift over here. So 25 will come over here, and 80 will come over here. So we are performing the L rotation among these three elements, 40, 25, and 18. So 25 and 18 and 40 will like over here, so there is no problem. And 17 is already in the red, and 15 is already in black, so there is no recolor is required here. Then 25 will be definitely black, but 17 and 15, for the 17 and 15 no recolor is required over here. So after performing the LL operation, we can perform this activity. So here we have the LL operation means 25 will come over here, and then after the LL, so 18 will come over here. So first 18 will come over here, 25 will come over here. So 18 will come over here, that is a left operation, and 25 is coming from this position. So we can say again we are performing the left operation, so that's why it is known as the LL operation. And after the changing its color, that is recolor operation, it is noted down that is okay. Now what happened? So it's following the properties of red black tree, and it is following the binary search tree. But as far as its balancing is concerned, so we need to manage its balance as well. But here in this example we're not managing, but we need to require, okay, but we need to require its rotation again after performing the operation. So at the last we have this kind of the tree, but before we need to see after 18. So 80 will come the right side of the 40, and same thing we need to manage all the properties and then the color. But here we have noted down that is the 17 and 25 are coming into the consecutive after performing the recolor operations. And again what we need to do, we need to change its color. So now you can note it down that again after performing the rotation, so after performing the rotation, 17 will become its root node, and 8 will become the left child of the 17. But 17 must be black, because now 17 becomes a root node. So this is our final example. So while managing all the things, it is better idea to first rotate and then recolor if required rotation. So while and as well as maintain the properties of the balancing. So definitely what we have the final the balancing tree. So very truly speaking, balancing is necessary, but why it is not a self balancing? It is maintained by the based on the colorized concept, the root node or parents node and children nodes, based on the color concept, red and black. Based on the red and black nodes, we are shifting our node from left to right or right to left, and this is also known as the left rotation, left rotation, left right rotation, and right rotation. And definitely all these kinds of rotation we have already discussed into the evil tree, and now it is performing the operation on the red black tree. So definitely it is a necessary part, and it must satisfy the properties of binary search tree, so it is also satisfying the same properties, so without any doubt. But it is better idea to balance the tree as well, as so that the definitely the answer will be in the correct way. So here at the last we have balanced the tree, but it is better idea to balance simultaneously confusion. So final answer will be the same. There is no doubt. There is no problem. So here we have the good example over here. So after adding the 80, so 80 will come over here without any doubt. So here we have the consecutive 2, and then 40 will come over here, 25 will come over here, and we need to see all this part. So there is no colorization over here. So now 25 will come over here, 40 will come over, 17 will come over here. So we will see all these properties. Okay, 17 यहाँ आएगा, फिर आएगा, एंड 40, तो हमको उसको बैलेंस करना पड़ेगा. सो बैलेंस करते 18 इज पार्ट ऑफ दिस वन, सो नो प्रॉब्लम. ओके, सो ये सब चीज़ें बहुत ज़रूरी है, देखेंगे. और 15 will be the part of the year. Why? Because 70, if 17 is root, then 15 is less than the 17, so it will be the part of the left subtree. So ये 15 यहाँ आएगा, but 15 is greater than its value of the left side, that is the 8, so definitely it will be part of the right side. So this part we have already discussed so many times. So this is the example of the red black tree. बेटर आइडिया यही है कि आप लेफ्ट सब ट्री मेंटेन करते वक्त, राइट सब ट्री मेंटेन करते, राइट और रेड ब्लैक ट्री मेंटेन करते वक्त आप हमेशा क्या काम करेंगे, कलर भी एडजस्ट करेंगे और साथ में क्या करेंगे, बैलेंस भी करके चलेंगे. तो इससे क्या होगा, आंसर आपको साथ में आता रहेगा. सपोज मैं पहले बैलेंस कर लेता, सपोज इफ आई बैलेंस साइमल्टेनियसली, सो व्हाट हैपन इफ आई नीड टू ऐड द 18, तो without any doubt 18 will come over here, so answer will be the same. If answer is just coming the difference, or your answer is showing the different way, so definitely what happened, you are going to the wrong direction. So please keep in mind all the properties. What are those properties are important, please keep in mind all those properties. New added node must be colorized the red. If two red consecutives comes, then we need to recolor the operation required to perform. And while maintaining its balancing, you can perform the rotation. And after performing the rotation, again it is noted down that the two consecutive reds coming, then we need to recolor. So recolor or rotation are the two different operations which are with the help of these two operations we can manage the red black tree, and there is nothing different. And implicitly your prerequisite operations or rotations are required, that is LL rotation, LR rotation, RR, and RL operations. So this is the most important part. And also maintain the properties of the binary search tree. So that is the what is the binary search tree property? The simple concept, the all the greater value from the root must be come from the right side, and all the values which is lesser than the root will be come on the side of the left. So this is the properties of the binary search tree and nothing else. So this is the red black tree. Now you have any doubt, then you can ask me, please. If you have any doubt here, then you can ask me.
सर मुझे ये जैसे 8, 5 और 15 सर, ये लेफ्ट सब ट्री है ना, तो सर 8 को तो ब्लैक होना चाहिए था क्योंकि वो रूट
8
हो
को,
गया.
हाँ, 8 को ब्लैक होना चाहिए था, मैंने मना नहीं, 8 रूट था ना, तो 8 को आपने क्या काम करा कि लेफ्ट की तरफ शिफ्ट करा, तो लेफ्ट की तरफ शिफ्ट करा है ना, तो ये करा था ना भाई, ये इसको शिफ्ट नहीं किया था आपने, क्या काम करा था, 8 पहले से रूट था, तो आपका क्या काम करा आपने यहाँ पर लेफ्ट रोटेशन अप्लाई किया, क्योंकि ये ट्री क्या हो रही है जहाँ बैलेंस नहीं हो रही है। तो इसको मुझे बैलेंस करने के लिए मुझे क्या करना पड़ेगा, 17 को यहाँ पे लेके आना पड़ेगा, ठीक है। 17 मेरा क्या रेड है, तो ये मुझे ब्लैक करना पड़ेगा, ठीक है। 8 मेरा यहाँ पर आ गया, ओके। 8 मेरा ऑलरेडी ब्लैक है, एंड फिर मेरे यहाँ पर 5 आएगा, ठीक है। तो होगा क्या, 5 ब्लैक हो गया, रेड ब्लैक हो गया, और 17 ब्लैक हो गया। तो इतने मैं ब्लैक नहीं लूंगा, पर मेरे कॉन्सेप्ट क्या है कि 5 इज वॉट, 5 इज मेरा मेरा क्या है, 5 मेरे क्या है, लीफ नोट है, तो डेट मस्ट बी ब्लैक, है ना। तो इसके लिए फिर मुझे क्या करना पड़ेगा, 8 is again black, so there is no problem right now, I can manage. But again it is notified that 17 is in red. When talking about the 17 is red, then its sibling is also should be red. So मुझे क्या करना पड़ेगा, 8 को red करना पड़ेगा, and that is the operation which is known as the recolor. इसलिए जब मेरा फाइनल ट्री आया, जब मेरा फाइनल ट्री आया तो 8 मेरा क्या हो गया, रेड हो गया, ओके। ये मुझे थोड़ा सा मेंटेन करना पड़ेगा। 17 सॉरी, यहाँ 25 आएगा क्योंकि शिफ्टिंग हो गई, ओके। सो 25 मेरा यहाँ रेड था, सो मुझे क्या करना पड़ेगा, 8 को भी रेड करना पड़ेगा। सिबलिंग ना, ये सारे स्टेप्स यहाँ पर लिखी हुई है ना। न्यू नोड्स पेरेंट सिबलिंग कलर इज रेड, देन पेरेंट्स नोड नोड is not root node, so we use recolor and then recheck. So basically it is a we can say it is a property of the traversion. While traversing we need to check कि कलर कौन सा है, कलर कौन सा नहीं है, एंड टू कॉन्जिक्यूटिव नहीं ले सकते। टू ब्लैक कॉन्जिक्यूटिव इज एप्लीकेबल, देयर इज नो प्रॉब्लम, टू कॉन्जिक्यूटिव ब्लैक इज एप्लीकेबल, even 3 consecutive black you can take, but while see we need to see its sibling is black or color, okay. So we need to see this part. And if you're looking for this example, कि sir here 13 and 53 are two different both are not sibling but both are not same, so we need to see that that is not a guarantee both siblings should be black, should be same level, but we need to also maintain this part. We also maintain this part. 13 could be a red, 13 could be a black undoubtedly, but what happened at the time, it is noted on the 3 consecutive we have, so we are not making the red black tree. What is the, here we have the black and we have the red and then black. So red, red, black, so one become the red, then black, and then red. Two black may come but two red can't come, okay. So this is the answer. But if you're taking the consecutive with 3 black, so this is also not feasible, so that's why we need to recolor, okay. So ये थोड़ा सा example है यहाँ पे,
Okay, sir.
okay. So now I'm just giving an exercise to all with these 6 elements. Please go through these 6 elements and let me know the answer. Initially the red black tree is empty, so first element, that is the 41, will be your root node, and that could be the black color start. And use your register copy, so you can do. So what happened on the notebook, you can't make your this note as a red or black because you don't have the pen red or black, so it is better idea to put the black B. So it means this is a root node and which is the black, for understanding purpose. Try to solve this question and explain me. हो गया, कर लिया आप लोगों ने?
We're doing so. Wait 1 minute.
Okay, okay, I'm waiting. Anish, what about you? Today you are sleeping, I think so.
नो सर सर मैंने गुड मॉर्निंग बोला आपको सर 8:36 में.
अच्छा अच्छा, नहीं मैंने रिप्लाई किया नहीं था।
नो सर आपने रिप्लाई नहीं किया सर.
हो सकता है कि मुझे कुछ काम, शायद हाँ फोन आ गया था एक बच्चे का, तो मैंने हेडफोन हटा दिया था उस टाइम
ये
पे।
सर आपका माइक म्यूट था.
हाँ वो एक बच्चे का फोन आ गया था उस टाइम पे। कंप्लीट, पर सिंपल सा क्वेश्चन है भाई।
Sir, can we exit?
ओके डन, yes it is done, yes it is done. Yes friend, done.
यस सर.
So Anish, who want to explain, Anish or other students? Now explain. So 41 is our root node, that is black. Okay, now what is the next step?
Yes, sir.
Now tell me what is the next step?
Sir 38.
38 where I should put?
Sir in left
Left.
side.
So left side. So it would be in form of the red.
Yes
Okay.
sir. Yes sir.
Next is the 31. So 31 will come left side of the.
Of 38.
So am I right?
हाँ sir.
Am I right? So again
Sir, a balance.
31 is what? No, no,
Red sir.
31 is red. Two consecutive red is not possible. Okay. So first
जी
we need to
सर.
see this so 31 will be the black. Can I do? Or it is better idea, to it in the rotation first.
Sir, first we can do the rotation, sir.
Yeah, definitely. It is
Yes
better
sir.
idea to rotate, and that is 38 and 41 and again 31. So this is the red, and this is the again red, and this is the again black. So what happened? So this is this property we need to follow. So this would be the 38 will be the black. And why black? Because it is a root node now, and these are red. So there is undoubtedly the 31 will be red. There is no color is required to change over here, and 41 is black. So we can maintain this property of the 31. Okay. So 41 okay, black is okay, but somehow we need to see this should be red, because at the same level it is notifying that is the it is notifying that, yeah, there should be red. Can I do? Can I do, or
Yes,
it is
sir.
not required
Yes,
to?
sir. Yes. Same
No,
rule.
sir.
Because
Yes, sir, required, sir.
it is required, or it is not necessary.
Sir, same level पे sir red.
Same level पे we can change, okay? Because at the
Yes, sir.
time we are following the property red black. In the red black tree, it means red, then black, and then red black. Okay, so we can change. Okay, so we are updating its color value. So now I'm just changing the option over here. Now this. Okay, so again I'm drawing the new or updated tree, that is a 38, that is a black. Here we have the 41, so I can say this is the red, and this is the 31, so we have the red. Now I need to insert the new node, that is what? 12. So 12, where I should I and insert?
Left of 31.
Okay, that is again what I'm getting. I'm getting the red. So these two could not be. These two could not be as a consecutive manner. So what I need to do? 12. I can make this
Rotation.
is a no rotation is required. Is rotation is required?
No, sir.
No, sir.
No, no rotation is not required, because what happened as per the definition of the balancing, the at most one difference is applicable. So definitely if we can do the height, so undoubtedly there is only the one difference, so it is applicable. So this tree is balanced right now, so there is no problem. Now this tree is also having the BST, there is no problem. But we can say this 12 is become as a black. But so I can change it. Can I change it? This is a black. Can I change this is a black or not?
Sir, leaf nodes are black रहेगा ना sir?
हाँ, तो 12 को ब्लैक कर सकते हैं,
Yes, sir. Yes.
पर ये तो न्यूली इंसर्टेड एलिमेंट है, तो हम रिकलर कर सकते हैं इसको, है ना?
Yes, sir. Yes.
ना now next is 91.
19, sir.
Okay, sorry, 19. So what about the 19?
सर वो अनबैलेंस्ड होगी सर, फिर LR लगाना पड़ेगा.
Yes, sir.
Okay, so what is the next step? Oh, I think okay, sorry, it is unshared. Okay, let me once again share. Now it is visible to all.
Yes, sir.
Yes, sir.
Okay, visible नहीं चली गई थी, हाँ. So now I'm coming back to the my point. That is okay. I just need to remove the few points, unnecessary part. Eraser. Okay. Next. Yes. So this is the balance. This is the balance as well. I'm changing its color. There is black. Undoubtedly, this is the right part. So 38. That is black I have. And after adding 19, so where should I add 19? 19 will come in this side. So what happened? This tree is again is not a balance. So now while balancing this tree, I need to perform which operation? Which operation should I perform? Which operation should I perform?
Sir, LR, sir.
LR. So first I need to is rotate into the left side. Okay. If I just rotate into the left side, so what happened? Yeah, this will be the 19, and this is our red, and so this is our red, and this is our red, and this is our this should be our 12, This is already into the black, but again this tree is not balanced, so we need to perform R operations. So R means rotations. So while making or adjusting this part, so I'm just removing or performing the operation. Please see and remove this part. I'm just making this part and balancing. Yes, yes, yes. So now 31 will be definitely undoubtedly no problem. That will be the black. 41 I have already changed into the red, so undoubtedly there is no problem. And 31 is what? 31 is our red already, so there is no problem. Okay, sorry. What I need to perform the it's a R operation, so I need to change. Okay, sorry. Yes, pen. So it would be 19. If I'm going to the wrong direction, please you can stop me. And here 31 will come, and here 12 will come. And please keep in mind the important words. 12 was the black and 31 was the red. Okay, and 19 is red. So these two red can't be consecutive in the red black tree. So this is our leaf node. So definitely we can make this is black. Undoubtedly 12 is already black. So this is the correct way. 31 is the black right now. So after changing its color, that is recolor. So this is the correct. And now 41 is already in red. But undoubtedly it is not in found that 41 itself is a leaf node, so that can't be a red. So I need to recolor it is in, it should be in black. Okay, am I right? Am I right?
सर आपने सर दूसरे स्टेप में 41 को रेड रिकलर क्यों किया था?
कहाँ पे?
और सर दूसरे स्टेप में सर
41 को रेड किया था, ये कह रहे हो ना?
यस सर
41 को इसलिए किया था क्योंकि सेम लेवल पे दोनों उसके सिबलिंग कैसे होने चाहिए, रेड होने चाहिए, क्योंकि हमारा न्यूली नोड ये था और जब हमने शिफ्टिंग करी थी तो 41 हमारा क्या हो गया, सेम लेवल पे दोनों रेड हो गए थे। पर ये फाइनली जब फाइनल ट्री हम बनाएंगे तो ये नोट करेंगे कि 41 को हम रेड नहीं रख सकते क्योंकि 41 हमारा लीफ नोड है राइट साइड, तो ये ब्लैक होना चाहिए। इसलिए मैंने यहाँ पर उसको एज ए ब्लैक कर दे। भले ही आप चीज़ को पहले फॉलो कर लेते या बाद में करो, लेकिन फाइनल ट्री में आपका ये कैसा होना चाहिए, ब्लैक होगा। ठीक है, इसलिए मैंने इस स्टेप पे इसको क्या कर दिया, रीकलर कर दिया।
ओके सर
ओके, क्योंकि अब जो नेक्स्ट एलिमेंट है वो 8 है, तो 8 तो ऑलरेडी राइट साइड जाएगा ही नहीं, तो इसलिए मैंने इस स्टेप पे इसको क्या कर दिया, उसको ब्लैक कर दिया। ठीक है, नाउ यू कैन ऐड द 8, सो 8 विल कम, वेयर विल कम, इट कम इन द लेफ्ट साइड। ओके, अब 8 कहाँ पर आएगा, यस
12
स्टूडेंट,
के लेफ्ट में
सर
12 के
12
लेफ्ट,
के लेफ्ट
12 के लेफ्ट में आएगा। सो इफ आई एम जस्ट पुटिंग ओवर हियर, then this tree is balanced or not?
नो सर
नो सर
No, so you need to perform the operation, then finally you will get your tree. So
Yes.
while maintaining what happened, the same level, at the same level all the node must be same color. This is the first point will summarize, I can say. If it is black, there is no issue because all the leaf nodes are the same level, so that could be black, so undoubtedly there is no problem. But if the same level, if the siblings are the red, but finally it is noting down that on the other subtree or other subtree or other part, it is noted down, it is already into the part of the leaf node, it can't be red, it should be black, so like the 41. So we have done this one. So without wasting much time, I'm just coming to the this part over here. Okay, so 31, 38, 38 was the correct answer. We have did it as a root. 41 is was the black, as I told you. 19 and 31, 12 and 8, it is added over here. Okay, so this was our answer, and now it is matching with this part. Am I right?
Yes, sir.
Okay, so now as per the property of the concept of red black tree, it is following the red black tree concept. So it is a red black tree, but the rotation is required. So you can perform the another rotation for its balancing purpose, then you can perform the next step. But if you're leaving your answer right over here, then it is correct. Okay, so no problem. At the last, what is the rotation? What is the operation? That is rotation. You can perform, but keep in mind the color is necessary because red black tree is saying that your the node must have the property of the red black tree, and in the red black tree it is necessary that you need to keep in mind the flip properties. And what are those properties? Please keep. What are those property? These are the six property, and here in this property, in the all this property, not rotation related word is not coming over here. So at the last, if your tree is not balanced after inserting the last element, but truly speaking, after inserting the last element, if tree is not balanced, then you you can't say your answer is wrong. You can say your answer is right because rotation is not required at the last after inserting the last element, because now tree is satisfying our property of the abundance tree. Okay, so we can say now this tree is self balanced because it is clearly showing picture that is okay, this tree is black and right, but finally it is noted down that sir, it should be the black. Yeah, of course it should be black. So you can manage or you can update this part as well. Okay, so you are required to manage this part, but this is a basically case. Okay, so which case belong to the case 1, case 2, case 3? There are three different cases, but I am not bothering about the different cases. So here you need to perform the another operation. So finally I got the this answer, but you need to update your answer by rotation as well as recolor. Okay, so this is another step, next step we have. But if you're leaving your answer after solving this part, so your answer will be correct because it is satisfying the properties of red black tree. So the root is black. Okay, this is the true part. And 19 is what? 19 is our 19 is what? 19 is our again left of tree. So it's satisfying. But if you're leaving this question over here, this tree is as here, definitely at the time your answer will be wrong. For changing its different scenario, how you can change, it is better idea to use null node. Okay, here you have to add null node, and that is known as the, I'm writing here nn, that is null node. So after adding null node you have to draw like here as a black. So now this is the correct answer. At the last, if you're leaving as a leaf node as a root red, so at the time answer will be the wrong. So it is better idea to add which node, that is a null node. So for understanding this purpose, now I'm here the other example. You can see now this example here. It is notifying that oh, all the most element are becomes the red. Now all the leaf nodes are the red. So as per our condition, as our properties, or the leaf node must be black. But what happen if I'm doing so? If I'm doing so, all the nodes becomes a black. But that day I'm changing the property, so recolor is not possible at the time. So the better idea to add the leaf node. So as I've added over here, है ना? तो सबसे बेटर आइडिया क्या है कि हर जगह आपका लीफ नोड ऐड कर दो तो आपका काम हो जाएगा. तो आंसर आपका क्या है कि आई जस्ट कमिंग टू दैट पॉइंट, आफ्टर एडिंग द ऑल द नोड्स हमने उसको रोटेट किया, कोई दिक्कत नहीं है. या तो एक तरीका ये है कि इसको रोटेट कर लो, ठीक है, उसको रिकलर कर लो तो आपकी नई ट्री बन जाएगी. दैट इज अ डिफरेंट थिंग, नो प्रॉब्लम. दैट इज कुड बी द नेक्स्ट लेवल आंसर. बट इफ यू आर लीविंग ओवर हियर, नो प्रॉब्लम. आफ्टर एडिंग द 8, now there is no balancing required over here, so it is better idea to put the new node, that should be the black. So now black, now black, now red, then black, then red, and then black. Here to consecutive black will be applicable, so there is no problem because it is a root node at the last. So what happened now, this tree is again is in form of the right answer. रेड ब्लैक ट्री में बस थोड़ा सा आपको ध्यान रखना है, अगर आपका लीफ नोड रेड आते हैं तो आपको क्या करना पड़ेगा, सारे के सारे लीफ नोड आते हैं, आप एडजस्टिंग करने के बाद या रोटेशन करने के बाद, तो बेटर आइडिया टू ऐड द null node. So then answer will be the correct. अगर आप ऐसा छोड़ते हैं तो आंसर आपका सामने वाला समझेगा कि नहीं सही नहीं है, तो आपको रोटेशन करके उसको कलर चेंज करना है. और फिर भी अगर लीफ नोड आपका अगर रेड होता है तो प्लीज ऐड न्यू नोड, सॉरी नल नोड. और नल नोड हम केवल एक ही जगह ऐड नहीं करेंगे, हम उसके सारे पार्ट पे ऐड करेंगे, एंड दैट इज योर फाइनल आंसर। सो ये थोड़ा सा ध्यान रखना है, यहाँ तक अगर डाउट है तो पूछ लीजिए। नाउ इफ यू आर feeling any problem here, then you can ask me. I'm speaking once again in summarized way. After inserting the last node, there is no balancing required. But if you want to balance your tree, then you can balance, and then you need to follow the rotation and recoloring property. And at the last, after recoloring a rotation, it is found that your leaf node is again in form of the red color. So it is better idea to put the null node to maintain your balanced tree properties. Same thing I have done over here. And while
Yes, sir.
adjusting, yeah, while adjusting or while adding the leaf node, now trees just become the balance. Okay, so there is no more extra work is required. So it is better idea to put the leaf node. Also, sorry, null node. Already 8, 31 and 41 are the leaf node, but I'm saying here we need to add the null node, as you can see into the my this diagram. Now this diagram I have taken from the not taken, actually this is drawn by the animated way. So I found over there, okay, if I'm not putting the null node or null value, so all the nodes, all the leaf nodes are becomes the red. But if I'm changing or recoloring, so what happened? It is a red, it is black, red and black. So root can't be black. So it is better idea to put the null leaf or leaf null. Okay, so null node you can add. Then this is the better solution. And this is the idea about the red black tree. Okay, now this is your answer. The sequence must be correct. Everyone will see the sequence 38, 41, 19, 31, 12, 8. ये वैल्यूज कहाँ पे आ रही हैं वो देखना बहुत ज़रूरी है। कलर वैल्यूज आपकी थोड़ी ऊपर नीचे में आएंगी तो सामने वाला चलो इग्नोर भी कर देगा, कोई बात नहीं। But the trees value where the what is the value of the left side, what is the value of the right side, and that is the most important part. Because you are not maintaining the properties of binary search tree, then how you can say your tree is having the concept of the binary search tree. So it is necessary to, you must have the properties of binary search tree, and then somehow at the last if you are doing some mistakes, then that could be ignorable. But that is the most important part, your tree must be BST. Now it is okay to all? Is it okay to all right now, or any doubt?
Yes, sir.
So I'm
Okay,
just
sir.
okay. Thank you. Deletion operation will in the red black tree will be the like the deletion into the BST. Suppose I am deleting the 12 over here. So then what I need to, again adjust where 8 should come. Okay. If I'm removing the 19, then I need to manage the all the property of the binary tree as well, and I need to rotate, re-rotation, each and everything I need to see like the deletion to the BST and able tree. So deletion is not important issue. Issue is to understand the algorithm for the insertion and creating. So while creating a red black tree, so insertion we are performing implicitly. So here we have the generalized algorithm. So this is generalized algorithm of the insertion a new node into the red black tree, and that is a check whether tree is empty or not. If it is not empty, then insert a new node as a root node and with color black. So this is the algorithm. So I will share this algorithm to all, and please go through this algorithm and you will find out. Okay. So here I am having the another tree. So I am going to the my next part, that the split tree. What is mean by the split tree? Split tree is basically is a tree which is again most important part. So right now I'm going to start now split tree.